Around 550 before Christ, a famous mathematician called Pythagoras started the questioning of how was the Earth formed. As he saw the moon and the sun circular shaped, he thought the Earth may have a tridimensional circular shape as well. This was where the discovery of the sphere started. Then Pythagoras raises that the planets are spheres and that they individually produce a sound as they rotate in the space, product of their form. Around 400 and 300 BC, Plato and Aristotle discovered and clarified the structure of an sphere. While Plato decided to talk about the aesthetics of the sphere and its beauty compared to God, Aristotle chose to talk about the continuity of its surface area. Nowadays, those discoveries that have been shown throughout the history by gorgeous mathematicians such as Pythagoras are used to create universal rules to measure things like the surface area of an sphere, to understand our world in a better concept.
Sphere surface area by Santiago Ortiz. In this case, A equals to area, so A equals to 4 times P times R to the power of 2. To demonstrate how the area of the sphere works, I will show you an example. The radius on this sphere is 30 centimeters, so we should multiply the radius by itself. So 30 times 30, we get 900. Now, 4 times P equals to 12.56 approximately. So then, as the equation says, we should multiply the result that we got from 4 times P by the result that we got by radius squared. The result we get from that is what we show down here. It's 11,304, so 11,304. To explain it down here, I have an example. I replaced the numbers that we have down here with the equation. So I filled the equation with the numbers so we can understand it easier. Now I will explain what is the formula for getting the surface area of this object. The formula for getting the surface area of this object is surface area equals to 4 times P times R squared. Another example of an sphere is the Earth. And based on the equation we saw before, what is the surface area of the Earth? So, I looked for the estimated radius of the Earth, and what I got was 6371, so 6371.0 kilometers. So, when I multiply it by itself, I get 405.89641. So, we multiply 4 times P, and that gives us 12.56, and then the result that we got from 4 times P we multiply, but then by the result we got from the square of 6,371, and when we do it we get a number that is supposed to be the one that would be the actual surface area of the Earth, and this one is 510,064,471. And when we look at the actual surface area, when we search it on the internet, we get a really close number. That is because the radius we get from the internet was a mean radius calculating from the South Pole.
Now I'm going to talk to you about the history of the ceiling. As civilization developed, so did the different rules for getting a shape's area. These were required for many numerous tasks, such as constructing dwellings of an appropriate size and shape, fashioning clothing or providing food or raw materials. Measurements have taken a great variety of forms over the course of history. Especially, the cylinder has been one of the most important shapes for geometry and mathematics through history. the ancient Egyptians, the Napoleon, and Hindus were the only ones who used forms for mathematics for doing many tests. The cylinder was initially divided into two parts: the area of the top and bottom circles, which are the same, and the area of the rectangle, labeled that wraps around the shape. This is why mathematics across the entire world presented that the usage of the cylinder is very challenging. So, because this shape wasn't invented in a certain time by someone, the first mathematicians needed to calculate the area of a circle and the area of a rectangle, so then they could have the area of the whole cylinder. In 240 BC, it was the Greek mathematician Archimedes who first conceived of a method of approximating the area of a circle by using polygons. For example, the area of a circle with a radius 1 can be approximated by inscribed polygons. After this, in 250 BC, in the book called On the Sphere and Cylinder, Archimedes, the author, he gives the formulation for calculating the volume of a sphere and a cylinder, in which this book was divided into different parts, in which he shows the readers his knowledge about mathematics. So, in measurements of a circle, he gives the approximation of the value of p with a method which allows improved approximation. In floating bodies, he presents what is now called Archimedes' principle, and begins his studies of algebraics. He writes works on 2 and 3-dimensional geometry, studying circles, spheres, and spirals. His ideas are far ahead of his contemporaries and include applications of an early form of integration. So, after finding how to get the area of a circle and a rectangle, Archimedes was able to advance in mathematics and became one of the most intelligent people in the world. This is why we could say that mathematics was very important in that time and in nowadays, because through these forms are used for many tasks, for example in constructions, in hospitals, and in other places.